Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mahiman bin Mahazam. I'm from mechatronics student, Bachelor Engineering Technology Mechatronic. My supervisor is Madam Husma binti Hussein and my co-supervisor is Mr. Amir Shahrizam Ismail. And my project title is Development of Electricity Collection System using Micro Hydro Generator. And the project category is Proof of Concept. So about the content of this slide, so we have introduction, literature review, methodology, result and discussion, conclusion and recommendation, and the last one is references. So about the introduction, power generation is a process of generating electric power from sources of primary energy such as wind, solar, hydropower and etc. So we want to produce electricity from mechanical power to electrical power by improving piping system. So this project is about to develop and analyze the electric power generated on house piping. So about the problem statement, global warming is a growing problem upsetting government and society in general and endangering health and environment. One of the ways to fight global warming is using green technology. Instead, burn fossil fuels such as natural gas to generate electric. This project can prevent from waste pollution. There is no researcher before this make an analysis of power generation by manipulating existing pipe in the home to supply electric. So about the objective, we have two objectives. The first one is we develop the mini hydro power generation and analysis system. And the second one is we want to analyze the electric power generated during peak time. So about the literature review. So there is three areas, which is power generation, method and result analysis. So at the first row by S.O. Anaza 2017, the technology was utilized in Himalayan villages within the form of water wheel to supply motive power to run devices like grinders. By Sulis 2019, the system is outlined by two primary steps of theoretical calculation and calculation-based development. By Liu 2021, this paper aimed to create a system where the input power came from water pipes energy harvesting system. So for method, Wei Yang 2019 carried on two parts, which is measure the external characteristic of turbine such as rotational speed, flow rate, pressure and torque. And next one is test the turbine startup performance. By Liu 2021, simulation circuit in the project is designed and tested in Proteus program. So for result analysis, Sulis 2019, water flow rate sensed by sensor. So Liu 2021, the parameter result shown on LCD display. For methodology, here is project flow. We have 8 steps. The first one is identifying the problem statement. So we setting the scope and state the objective. So for step 2 engineering study, we make a feasibility study on mechanical and electrical system. The third one is design drawing preparation and approval. And the next step is step 4, we survey the standard part. At this step, we also purchase the mechanical, electrical and electronic parts. So for step 5, we develop the mini hydro power generation and analysis system. We assemble all parts in this step. So the next step is step 6. We test the system, test and train. And the next step is step 7. We analyze the data. We evaluate and compare the findings. The last step is report writing. Include all result and analysis. So here is the hardware and process flow. The first one is water pump. So water pump will make the water flow to pipelines. So we use pipe valve to control and adjusting the speed of water, and the water will flow to micro hydro generator. So micro hydro generator will produce electric, and the power generated will flow to DC step down. So for DC step down, we want to regulate the voltage from 12 volt to 5 volt because current sensor only receive 5 volt. So current sensor is to sense the current, and then here is Arduino Uno, and then we will display current produced on LCD. And this one is Wi-Fi module. We want to send the data that we collect, which is current that produced, to ThinkSpeak website. So we use laptop to compile and upload the program to Arduino Uno. So here is the assembly design. This one is mechanical design. We design it using SolidWorks. And electrical design, we design it using Proteus. And here is the assembly for hardware, electric and mechanical components. So for Gantt chart FYP1, submission of FYP logbook from week 7 to 17, all week. So for submission FYP proposal registration form and proposal on week 7, proposal approval within 1 week, which is week 8, proposal revising within 2 weeks from week 9 to week 10. So we continue proposal writing within 4 weeks from week 11 to week 14. And final proposal submission within 2 weeks from week 15 to week 16. And the last one is proposal presentation on week 17. So Gantt chart for FYP2, submission of FYP logbook on every week. So we survey standard part for this project on week 1, and design and drawing preparation on week 2 until week 3, so within 2 weeks. So we purchase hardware and standard part on week 4. We do assemble and programming testing within 1, 2, 3, 4, 5, 6, 7 week, from week 5 to week 11. And then we do analysis and record the data from week 11 to week 15. We write the report on week 3 until week 15. So we submit the FYP report on week 16, and then FYP2 presentation on week 17. So for project cost, so here is the list. All of the item have only one quantity, so here is the price for each component. So here is the total project cost, which is 209.04 cents. So about the result and discussion. So basically this is the table for hardware testing. The current produced is being measured between 12 am to 9 pm and displayed on LCD display. So here is the LCD display for selected test hour. So the goal is to determine how much the current produced during those time. The result of the current produced shown in the table. So about the project demonstration video. So this is our project. So firstly, we will turn on the AC-DC adapter and we'll activate the water pump. Water pump will make the water flow through pipelines. So we use pipe valve to control the speed of the water. So here we can control from pipe valve. And here is micro hydro generator, and water will go out here. The power generated will flow to, so this is step down. We use it to regulate the voltage from 12 volt to 5 volt. This is because the current sensor only receives 5 volt. So here is the current sensor INA219 to sense the current. So we connect it to Arduino Uno. So we use Wi-Fi module to send the data to ThinkSpeak website. So this one is the LCD display. We will display the current produced and also the voltage. So we use USB cable to connect it to laptop for programming. So the next video is we will adjust the speed of the water. So we adjust the speed of the water to see the current reduce or not. So right now the current reduced from 0.12 to 0 milliampere. So the next video is we want to send the data, the current, using Wi-Fi module. So right now the current is 2.4 milliampere. So we want to send it to ThinkSpeak website. So here is the ThinkSpeak website. So right now the current is 2 on the chart, and here is the current produced that ThinkSpeak detect from Wi-Fi module. So for data analysis, at 12 am the current produced is 0.2. So at the chart it points on 0. So at 8 am the current increasing to 10-20 milliampere. So at 3 pm the current reduced to 2.08 milliampere, and the current start increasing back to 5.15 milliampere at 6 pm. At 9 pm, which is the current is 3.42 milliampere. So we can conclude that the faster the speed of the water, the higher the value of the current. The peak demands within a day typically occur in the morning hours within 8 am, when residents wake to begin their daily routine. The usage of water starts decreasing until 3 pm and start increasing back at 6 pm, when residents need to clean up after returning home and starting their night routines. So for conclusion and future recommendation, so for project conclusion, so project is achieved because met the objective, which is we develop the mini hydro power generation and analysis system. The second one, we analyze the electric power generated during peak time. What we learn is the integration of Arduino, Proteus and SolidWorks, and a small portion of maintenance, inshallah, will increase my knowledge. So the limitation due to the pandemic, it is hard to meet the technical advisor face to face, but Alhamdulillah, I managed to finish the project with help of supervisor and project coordinator through online. May Allah bless them. Ameen. So for future recommendation, the first one is the weakness is the current generate insufficient. As you can see in this video, the current is insufficient. Make the power module for power bank keep repeating, keep turn on and turn off, as you can see here in the video. Off, on. The lamp is blink because the current is insufficient. So we can employ a high power generator. This is because the current may be used to store energy in a power bank if the current is sufficient. The second one, the motor pump move the water in pipelines too slow. For further work, need to use high power of water pump, so that this project can use water flow sensor to get another data to do analysis. So here is the references in these slides. So we have 5 references. So for Q&A, question and answer, if you have any question, you can email me on this email, and you can contact me on this number contact. That's all from me. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.